friends, I just wanted to jump in here to do a little intro for this video. This review, I can't take credit for the problems. They were written by the subject lead on this for MATH125. But I wanted to give you a step-by-step example for the problems that you're going to experience on the exam. So I've taken time to go through and work all of these review problems. I've used the Desmos graphing calculator. I've used the formula chart, all of which I've linked in the description. So please make sure you have those open when you dive into this review. Every problem is crafted to help you do well on a question on the exam. So I'm hoping you take advantage of them, watch all the way to the end so that you get the benefit of those. And thanks so much for joining in. Bye for now.
Let's take a look at this problem, watching the units carefully. So a medication comes in a liquid form with 200 milligrams of medication per milliliter. How many milliliters is required for a 450 milligram dose? Now, I like to work this problem backwards. So I notice that I want the answers to be in milliliters. Now, with our units, we need the milliliters to stay. So those are going to have to be on top of our first fraction. So look in your problem, where do you have milliliters? Well, I see it in the second line here. We're told that it's 200 milligrams per 1 milliliter. So I'm going to build my fraction with that. I have 1 milliliter and I have 200 milligrams. So you see how I use the second line to build this fraction in the problem side. Then I know that in order for milliliters to be in my answer, these milligrams have to cancel. So I'm going to need a milligram on top to cancel here with the milligrams on bottom. So look in your problem again. Where do you see milligrams? That's right. In your last line, we see the 450 milligram dose. So we'll put our 450 here. Notice that because you have a milligram on top and a milligram on the bottom, they cancel. And now you can multiply across the top. 450 times 1 gives you 450. And then across the bottom, you have 200. And then this is where you go to your calculator and do your division there. 450 divided by 200 gives you 2.25 milliliters. And then you want to be sure and watch your rounding. You know, if the problem asks you to round to the nearest tenth, of course, you'd answer 2.3. But if it asks you to round to 2 decimal places, 2.25 there. For this problem, a medication is dosed at 15 milligrams per kilogram body weight. How many milligrams should a 225-pound person get? So again, for this problem, I want to look at the answer first. So we were asked for how many milligrams. So I'm going to build my problem backwards. I start with what I know the answer's units need to be. And in order for milligrams to be in the answer, I've got to have a milligram on top here. Now look in your problem, where do you see milligrams? I see it right here in that first line. It's 15 milligrams per 1 kilogram of body weight. So we're going to build our fraction with that, 15 milligrams per 1 kilogram of body weight. Okay, and now I know that I've got to have kilograms on top, and because I need those kilograms to cancel so I can be left with milligrams. Now, the only other number in the problem I have is the 225 pounds, and I don't have any more kilograms, but I do have a conversion on my chart that tells me kilograms to pounds. So this unit here told me, kind of gave me a hint as to what I needed to go to the conversion chart for. So I'm going to do kilograms and pounds. Notice in the conversion, it's 1 kilogram with 2.2 pounds. And notice very nicely, then my kilograms would be canceling. I still want the milligrams as my answer, so I need these pounds to go away. And so when I put the pound here, I would use that 225, okay? So again, once now I've worked from the answer backwards, I can set up this problem. I can multiply across the top. 225 times 1 times 15 gives me 3,375. And then on the bottom, I've got 2.1 times 1. Obviously, that's 2.2. And then you can go to your calculator and divide there. Now this one, I'm going to go ahead and round to 2 decimal places. This problem did not tell me, and that's 0.09 there. This problem did not tell me what to round to. I mean, if it told me to round to the nearest tenth, I could have rounded to 1,534.1 milligrams. I'm going to leave the rounding to you. Really practice and read carefully in the problem so that you know exactly what you're rounding to. But again, this is an idea of where I'm building the problem from the answer backwards. All right, let's take a look at another one. We have a medication in liquid form with 200 milligrams of medication per milliliter. Medication needs to be infused at a rate of 10 milligrams per minute. What is the infusion rate in milliliters per hour? And I'm focusing on starting with the answer. So notice I have milliliter per hour. That's giving us a clue as to what we want left in this problem. So I know that I've got to have milliliters on top. Look at your problem. Where do you see milliliters? I see that in the first sentence. We were told 200 milligrams of medication per 1 milliliter. So I'm going to put 1 milliliter and 200 milligrams. Okay. Then I do need the milligrams to go away, because I need them to cancel and leave me with those milliliters. So look in your problem, where do you see the milligrams? I see 10 milligrams per 1 minute. So I've got 10 milligrams per 1 minute. And then, of course, the milligrams will cancel. That works nicely. Now my answer tells me I want hours. So my minutes have got to go away. So I need my minutes to go away. And this one is a conversion because I want my minutes to go away. I want my hours to come into the problem. So this is where you can go to your conversion chart and get that 60 minutes is 1 hour. And notice then now you have everything set up to cancel. Your milliliters are going to stay on top. Your hour is going to stay on bottom. That's what we wanted there. So let's multiply across the top. 60 times 10 will give us 600 times 1 gives me the 600 easily there. And then on the bottom, 1 times 200 gives me the 200. And now this is where you can do your division. And you get 600 divided by 200, you get 3 milliliters per hour. Okay. Again, now this is our third example of working the problem from the answer backwards so that we get the units to line up just like we want them. All right, let's take a look at another one. A medication is dosed at 8 milligrams per kilogram body weight. The medication comes in a liquid form with 12 milligrams of medication per 1 milliliter. What dose in milliliters should a 100 kilogram person get? So again, working that problem from backwards, we're going to put our milliliters in our answer because we know that's what the answer should be in. And so we've got milliliters on top here. Look in your problem. Where do you have milliliters? Looks like sentence 2 told me 12 milligrams of medication per 1 milliliter. So I'm going to put that in my fraction, 1 milliliter for 12 milligrams of medication. Of course, now we need those milligrams to go away because we want the milliliters to stay. So look in your problem, where do you see the milligrams? So a medication is dosed at 8 milligrams per 1 kilogram of body weight. So we'll put that in 8 milligrams for 1 kilogram of body weight. So nicely, those milligrams are going to cancel for us. And now we need the kilograms to go away. So we need kilograms to go up here. Where do you see in the problem a kilogram? Well, you've got that 100 right there. And nicely, your kilograms are going to cancel. So this is where you're ready to do your multiplication across the top. So 100 times 8 times 1 gives me 800. And across the bottom, 1 times 12 gives me 12. And now you're ready to divide. 800 divided by 12, ooh, I'm going to have to round. So I get 66.6666. Let's say we wanted to round to the nearest tenth or to 1 decimal place. then I would do 66.7 milliliters. Okay, again, building from our units at the end of the answer and building our problem backwards. Always looking for what do I need to keep? What units do I need to keep? What units do I need to go away? All right, our next group of problems are from Module 8, so it's going to look a little different, but there are some problems like this on the test. I want you to be ready for those. So let's take a look at these here. If we're looking to combine like terms, I want you to remember that like terms have the same variable and the same exponent. Always be watchful for those numbers or terms that are in front of a parentheses. That's where you're going to use the distributive property. So you're going to distribute the 2 here to multiply. So these terms in front, not going to do anything with them yet. I will in a moment, but let's multiply the 2 as we distribute it. 2 times the 5x, that'll give me 10x. And then 2 times 2 will give me the 4. And now I'm looking for those like terms. Same variables, so I'm going to do the 4x and the 10x, going to combine those first. So 4x plus 10x, I want you to think of that like 4 apples plus 10 apples gives you 14 apples. And then watch your signs here. Watch this negative here. That is a minus 8, but I really want you to think of it as plus negative because I want you to think of negative 8 plus 4. If you want to punch that in your calculator, you're going to get a negative 4 here. Now, the 14x and the negative 4, can't combine those because they do not have the same variable. So my answer here, 14x minus 4. And I can't simplify any further than that. In our next problem from Module 8, I want to focus first of all on the instructions, say to evaluate. That means you're going to give a numeric value for. What is it we want a numeric value for? Well, we want the numeric value of this expression if we put 5 in place of x. So when you see 3x, you're going to rewrite that as 3 times 5. See, writing a 3 beside an x means that 3 times x. Then you're going to have minus, and there's parentheses. Now you have 2x, so that's 2 times 5 plus 3. Now you've substituted it, and now you can go through your order of operations. Okay? The P stands for parentheses, so you're going to do what's inside the parentheses first. That means we're going to do the 2 times 5 first. I'm just going to leave this 3 times 5 out here. I'll do the 2 times 5 first. That gives me 10 plus 3. And still inside the parentheses, I'll go ahead and add the 10 and the 3 gives me 13. All right, now my parentheses is done. I don't have any exponents. Now I need to multiply or divide. So 3 times 5 gives me 15. And 15 minus 13 gives me 2. Now, friends, you can type this line right there in your calculator. Hopefully, you're using the Desmos graphing calculator. If you need the link for that, it's down in my description. You could type that in your calculator. Your calculator is going to return the same answer for you. So you have to make the substitution. Then you can type it in your calculator. The calculator will do the calculations for you. All right, our next problem from Module 5 says, is 5 the solution set for this problem? Let me reword this for you. It's asking you is, if x is 5, do you get the same value on both sides? Let me say that again. If you substitute 5 for x, do you get the same value on both sides? Well, let's check it out. I'm going to put 5 in place of x. You remember from our last problem that when you have 2x, that means 2 times x. So I'm going to do 2 times 5. All I'm doing is replacing the x with a 5. I want to know, do I get the same number on both sides? Put a little question mark there because we're not sure yet. Now let's do the calculations. 2 times 5 gives me 10. 10 minus 7 gives me 3. Other side, 4 times 5 gives me 20. 20 plus 12 gives me 32. So the answer to my question, if I replace x with 5, do I get the same number on both sides? The answer is no. No, I do not. Now, if you want to check yourself, you want to make sure you're doing the order of operations right. Remember, you can do the substitutions, and then you put this in the calculator, and you put this in the calculator, and see, do I get the same number? If I do, then the answer to my question is yes. If I don't, then the answer to the question is no. All right, our next problem for Module 8 is to solve the equation. So what we're going to try to do is get x by itself on one side of the equation, get everything else on the other side. I am noticing these parentheses. They are like jumping out at me, so I know I have to spend some time with those first. I'm going to distribute this 4. Now remember, when we say distribute, that means we're going to multiply. So I'm going to leave my 3x plus 5 over here. I'll do 4 times 2x. That gives me 8x. I'll do 4 times 20. Jumping ahead of myself. 4 times 7 will give me 28. Now remember, I got to get all the x's on one side of the equation first. So I've got to move this 8x here. It's positive, so I'm going to do the opposite, which is to subtract. So 3x minus 8x will give me negative 5x. Notice my 8x minus 8x, those cancel. That's by design. I did that on purpose. Don't lose this little negative there in front of the 28. That's really important. All right, notice my x's are all on one side of the equation. Now we start moving the numbers away from that x. So we'll deal with the plus 5 here. We'll do the opposite, which is to subtract 5. If you're kind of shaky on your negatives, definitely put that negative 28 minus 5 in the calculator to check yourself. You'll get negative 33. And then and notice that the negative 5 is being multiplied by x, so we'll do the opposite, which is to divide by negative 5. And of course, you could put that negative 33 divided by negative 5 in your calculator. You're going to get positive 6.6. I like those. Okay. If you want to check yourself, we did this in the last problem. You put 6.6 in for x on this side of the equation. That would look like 3 times 6.6 plus 5. You would put 6.6 in this side of the equation as well. 4 times, parentheses, 2 times 6.6 minus 7. Make sure you get the same number. Should get the same answer for both sides of that. That'll let you know that you have the right answer for this equation. Let's go ahead and move on to Module 9. And in this problem, we have a medication that has a half-life. And I think that's the important phrase here. When we look at half-life, I want you to look at the formula chart, which of course I've put in a link in the description below. On the very last page, on the very last formula, you're going to see that half-life formula, okay? So before we look at the problem, I want you to look at the pieces of this formula. We are told that the amount is equal to A, and then we have a parentheses 1/2, and then an exponent of t divided by h. And look at the pieces you're looking for. You're looking for A as the initial amount. So when we read through the wording, we're going to be looking for that initial amount where we're told that TH, or what I've said is H, is the half-life. We'll be looking for that. And then we'll also be looking for T as the time. Okay, so as we read the problem, be thinking about what is the initial amount, what is the half-life, what is the time. So let's read through the problem. So a medication has a half-life of 4 hours. So this is the H I'm talking about, or the TH in this formula. So I'm just going to put a little TH by the 4. Sentence 2, if the initial dose, it's another way of saying initial amount, is 200 milligrams. So this is our A. How much medication will be in the patient's system after 8 hours? And that is our time factor there. So as we look at the formula, we've now identified the value for each of these variables. Let's plug them in. I've got amount equals, and then A, we'll look back at our problem. We labeled the 200 as A. So I've got 200, and then I've got parentheses 1/2, and then T, that's our time, 8 divided by, and then our TH or our H here, and that's our 4. Okay. Now, I think sometimes that the hard part in this is actually like typing that in the formula. So let's take a look at how we would do that. I'm going to do it with Desmos. I'm just going to type it in because I want you to see how important it is we type it in correctly. So I'm going to put my 200 and then my parentheses 1 divided by 2. Now, I've got to get out of the parentheses here, so I use a right arrow to get out of the parentheses so I can close the parentheses here, and now I need to get in the exponent. And the way to do this is you hold the shift key down and you press the number 6. Did you notice the little cursor went up into the exponent? That's what we want. And then we do 8 divided by 4. If you'll type it in exactly like this, Desmos will do the heavy lifting for you and give you the answer that you need. You could see it's easily 50 milligrams, okay? But very important that we type it in just like this. Let's continue our work here for Module 9 by looking at this problem. A patient takes 1,050 milligrams of a medication. The nurse says that this is 250 more than 3 times the normal dose. What is the normal dose? Okay. Now, at first glance, this problem may look like a unit conversion. However, our answer is not asked for in a different unit, meaning we can still answer in 50 milligrams. So this problem is not about converting to a different unit. This is about translating this second sentence into an equation. So let's read the second sentence with a little bit more clarity. The nurse says that this, meaning the medication, this is keyword for equals, 250 more than, that's keywords for add, 3 times, obviously, 3 multiply the normal dose. Okay, so what we're doing is we're taking that second statement, we're translating it. The nurse says that that's the patient, the medication they're currently taking, 1,050, is, keyword for equals, 250 more than, 250 plus, 3 times, 3, and I'm going to use a little dot here for my times, the normal dose. Now, the normal dose is what we don't know. How do I know that? Because the next question says, what is the normal dose? We don't know that. So I'm going to pick a letter. Well, you want it to be X? You want it to be N? Maybe I'll use normal. I'll do N. And what we're doing, friends, here is to solve this equation. We've got to get N by itself. Forgive my little curly N there, but let's solve, right? We've got to get N by itself, so I've got to move this 250. I got to do the opposite of adding 250, so I'm going to subtract 250. And that gives me 800. You can check that in your calculator if you need to. My 250s cancel out. I'm left with 3n, or 3 times n. Now to get n by itself, we do the opposite of multiplying by 3, which is to divide by 3. And I'm going to get that n is 800 divided by 3. Now I'm writing it out like that, but of course I want you to go to your calculator. I want you to put that in your calculator to get 266.6 repeating. Now watch your instructions. Maybe your instructions say to round to the nearest hundredth. Maybe your instructions say round to the nearest to 1 decimal place. You're going to watch your instructions carefully, but this is how you actually set up the problem. So I want you to watch. Sometimes when we're talking about medication problems, we're not really even looking at unit conversion. Instead, we're looking at, can you translate this into an equation and then solve for the unknown, which in this case was the normal dose. All right, now Module 9, again, takes a little bit of an approach with coefficients, like terms. So let's refresh our memory. What are coefficients? Coefficients are the numbers in front of the terms. So I'm going to point to them here. Here, notice they're in front, and here. So if I were to list those, I have a coefficient of 4. Watch this one carefully in the middle. I have a coefficient of -5. Ooh, where'd you get that, Dr. May? The minus here could actually be rewritten as plus a negative, which makes our coefficient a -5 there, and a 7. All right. Now, second question, are there any like terms? So I want you to think like terms have the same variables, aka same letters, and same exponents on those letters or variables. Okay, so look here, I've got A. That's good. I've got B. That's, they have A's and B's. This one has a C. Oh, the one in the middle doesn't have a C. It can't be a like term. This one has a C. Can be a like term. But notice that the one in the front has an exponent of 2 on the A, and the one in the back does not. So are there any like terms? The answer here would be no. Do they have the same letters? Well, 2 of them do, the first one and the last one. But those letters don't have the same exponents, so I don't have any like terms here. Now, in this problem, let's take that one step further to combine like terms. So we want to look for the ones that have the same variable and the same exponent. So for ease sake, I'm just going to underline this one. Notice it has a to the second, b to the third, c. And this one has a to the second, b to the third, c. So how do we combine those? Well, we add the numbers in front. But that sounds too simple because I have this minus sign here. I'm going to have to change that to a plus and change the sign of the next number. So now really I'm adding 4 plus negative 17. And you can put that in your calculator. You're going to get negative 13. And then don't forget those letters and exponents behind. Those are very important. We want to keep those together. Notice I didn't do anything with the exponents. I didn't add those exponents of 2. I left them as is, okay? Now let's look for the next set of like terms. And you'll notice I have this a to the 5th b and this a to the 5th b. Again, I've got that minus going on, so I want to change that to plus by changing the sign of the next number. So we're going to add those numbers in front. I'm going to add the negative 5 and the 8. That's going to give me 3, positive 3. Check it in your calculator if you need to. Then I've got a to the 5th b. Remember, when we combine like terms, we don't change the exponents at all. Now, I want you to draw your attention to the last term we haven't used yet, and it doesn't have a like term. That doesn't mean it gets left out. That just means it gets added on the end. We actually cannot combine it with anything else. And friends, as complicated as this looks, this is my final answer here. Okay? So what did we do? We identified the like terms, same variables, same exponents. We added those numbers in front, watching for the minus signs, changing them to plus and negative. Added those numbers in front, wrote the letters behind it with the same exponents. We didn't change exponents at all. And we have our final answer here. As complicated as it looks, this is my final answer. Now let's switch gears just a little bit as we move into Module 10, which had a little bit of geometry going on. So we're going to start talking a little bit about lines and those kinds of terminology. So in this question, we're just asking, is it true or false? So if 2 lines are perpendicular, that's a big word, we got to think about what that means. If 2 lines are perpendicular to the same line, then the 2 lines are parallel. So what does perpendicular mean? Well, perpendicular means that they form a right angle or a 90-degree angle. When I teach this to younger students, I tell them it makes a perfect corner, right? It makes a perfect corner. So let's think about in a simple case, I've got a line and I've got 2 lines that are perpendicular to it. So I'm going to draw a line here and a line here. I'm kind of one of those people. I like to put the arrows on the end of my line. And I know that these 2 lines, if they're perpendicular to the horizontal line, then they make a little right angle. They make a perpendicular, they make a perfect corner, right? So let's call this line A, right? And we'll call this line B. Just for ease, we'll be able to talk about them. So what we're asking is if B and C are perpendicular to A, meaning they make a right angle with A, then B and C are parallel, meaning that they don't ever touch. Think about that for a moment. Do you think yes, true, or false, no? I agree this is a true statement, okay? If B and C are perpendicular or they form a right angle with A, then B and C are parallel. Now, friends, here's the beauty in this problem is that this is a math question. There are no equations to solve. We don't get x equals 2. And I'll be the first one to tell you, I love when x equals 2. But this problem is about reading the words and understanding what they mean. I always like to do a picture because I think a picture is worth 1,000 words, right? If I can put a picture to it, it tends to make a little bit better sense for me. So I would encourage you to do the same. All right, remember here in Module 10 that we are dealing with a little bit of geometry. So we are asked here in this problem to find the complement and the supplement of an angle of 73 degrees. So complement, again, just like we said in the last problem, this is about reading the words and understanding what they mean. So complement means they add to 90. And supplement means they add to 180. So if I'm going to do the complement, and those are supposed to add to 90, then in order to find the complement, I'm going to take 90 degrees and I'm going to subtract 73. Again, put that in your calculator. You can do that subtraction easily. But again, the difficulty in this problem is reading it and knowing what to do, right? So that's my complement. And so I bet you can guess for my supplement, and then I'm going to take the 180 and I'm going to subtract the 73. And I'm going to get 107. Okay? So complement adds to 90, supplement adds to 180. So if we know one of the angles, then we're just going to subtract it from 90 to find the complement. We're going to subtract from 180 to find the supplement. All right. I love these types of problems here where we have two parallel lines. Just like in one of our previous problems, I'm just going to label these as A and B because A and B are parallel here and C is our transversal. And what we want to do is to find all the angles, okay? So let's think about, first of all, let's find number one, angle number one. I want you to notice that angle number one and 122 degrees form a line. And we know that a line adds to 180. So if I have 122 plus angle 1, I'm just going to call it, we know those have to add to 180. So in order to find angle 1, what I'm simply going to do is take 180 and subtract 122. Okay? I like the ones that I can just make a straight line with because it makes it a little easier for me to be able to I just know that those add to 180. So that's pretty simple. So I know that this one is 58. Okay. Now here's the fun part. Now I want you to get 2 and 3, angles 2 and 3 pretty easily because you can see they are vertical angles. What that means is you have an X, the angles make an X. And so you know this angle and this angle, they are across from each other. Those are called vertical angles. So we know that angle 2 has to be 58 because it's a vertical angle with angle 1. And you know angle 3 has to be 122 because it's a vertical angle from the 122. Did you see how we got those pretty easy? Didn't even have to do any calculations with them really. All right. So now that you know angle 2 is 58, then here's the beautiful part. If you look at the bottom, you look at the angles around line B, I want you to see that angle 5 is in the same location as angle 1, meaning they're in the top right of the transversal and line B, okay? So what that means is that angle 5 is the same measure as angle 1 because they're what we call corresponding angles. And angle 4 is in the same location as the 122. They're in the top left from line B and the transversal. So I know those two have to be the same. So here's what we get these pretty much for really easy, right? Angle 4 has to be 122 because it's in the same location as angle 1. I'm sorry. Angle 4 has to be 122 because it's in the same location as the 122. Angle 5 has to be the same as angle 1 because they're in the same location. We call it corresponding angles. So this one has to be 58. Okay? Then I want you to see that angle 6 is in the corresponding place with angle 2. So we know that angle 6 has to be 58. And I know that angle 7 has to be the same as angle 3 because, again, they're in corresponding places. So, friends, here's what I want you to see in this problem. We did one calculation, right? We did the first calculation, which was to subtract 180 and 122. That got us angle 1. The other angles I got simply by identifying were they a vertical angle and what was their corresponding angle measure. Okay, so this problem looks like, hey, I've got to find 7 things. I'm going to have to do 7 equations and these big, long calculations. You really don't. If you can identify, is it a vertical angle? What is the measure of its corresponding angle? That's going to be your key to unlocking all of these values here. All right, let's go ahead and move into module 11. In this one, we're told that a rectangular wound is 10 centimeters long and 8 centimeters wide. What's the area? So I'm a picture person. So I'm going to draw my rectangle. Forgive me if it's not perfect quarters. And then I label. It's 10 centimeters long, so I'm going to put 10. And 8 centimeters wide, I'm going to put 8. And you can go to your formula chart to find the area of a rectangle. I want you to be sure that it's the area of the rectangle. And you will see that it is the length times the width. And when we put these values in here, we're told the length is 10 and the width is 8. Oh, forgive me there, writing that 8. There we go. And 10 times 8, you can easily see is 80. And then watch your units here. It's centimeters squared or square centimeters there. Be real careful with this one. You have, there's a difference between asking for the area and the perimeter. So make sure you use the right formula from your formula chart. Again, I'm linking that down below for you to practice with. Let's turn our attention then to circles here. In this problem, we are told that flowers are to be planted at the edge, that's important, of a circular flower bed with a radius of 6 feet. If the flowers are to be planted every 8 inches, notice the units are different, 6 feet, 8 inches. How many flowers are needed? So when we talk about the edge of a circular flower bed, you have to know we are talking about circumference then. Circumference is if I were to walk all the way around a circle, I would be walking the circumference, and that's the edge. So that's a key phrase there. Again, this is going to your formula chart to get the circumference, which we are told that is pi times the diameter, or we are told that it is pi times 2 times the radius. Okay, so those are one of my 2 formulas I'm going to use. I'm going to get those from my formula chart, again, linked in the description below. But I really want to focus in on this. Notice the units are different, okay? So in order to deal with flowers planted every 8 inches apart, I need my radius to not be in feet. I need my radius to be in inches. So this is where I want to take my radius. I want to take my 6 feet and multiply by 12 because there are 12 inches in a foot, and I want to get 72 inches. Okay. Now I can go to my circumference formula. Pi times 2 times 72. Now you may be asking yourself, Dr. May, what are we going to do about that pi? I'm glad you asked. I would use it as 3.14 right now, because I think it's going to be pretty simple to do that in my calculator. So I'm going to type my 3.14 times 2 times 72, and I get 452.16. And remember, this is inches, okay? That's just to get the circumference. Friends, we have not answered the question yet, okay? That tells me how far it is around this flower bed if I were to walk it. But I want to know how many flowers I need if I plant my flowers every 8 inches. So I'm going to have to divide by 8 here to get my number of flowers. And I get 56.52. Okay. So how many flowers do I need? I actually need 56. I won't get to the 57th one. 56 flowers. But here's what I want you to know. This was a three-step problem. This was a problem where, first of all, I had to identify that it was the circumference. Remember, that word edge let me know that I was dealing with the circumference. I had to convert my radius from feet to inches because my flowers were being planted every 8 inches. So I had to first calculate the circumference in inches. Once I did that, then I had to divide by 8. So a multi-step problem here that involved a little bit of unit conversion. So I want you to watch those units and then also notice that I used 3.14 for my pi value. So I hope that that helps you with that one. Staying in module 11 here, I want you to work through a problem here. What is the area of the carpet needed to cover a circular area with a radius of 5 feet? So circular means I'm going to go to my formula chart. I am looking for the area formula for a circle, and that is pi times the radius to the second power. So I'm going to plug in my values. So using pi as 3.14 like we did in our previous problem, I've got times, and then I've got my 5 to the second power. And this is where I want to go to my calculator. So let me bring over that Desmos calculator. And this is where I just want to type in my 3.14. You can do your times and then do 5, and then you've got to get in the exponent. Remember how we do that? It's shift 6. Puts me in the little exponent, and I can type my 2 there. And so I get 78.5 as my area here. Watch how you type it in. Remember, you've got to get that exponent in. You've got to get the 2 in the exponent in order for Desmos to calculate the right value for you. Let's look at this problem here. An isosceles triangle has one angle of 110 degrees. What are the measure of the other 2 angles? So in an isosceles triangle, what we know is that 2 sides are equal, and we know that 2 angles will be equal. So let's see if we can draw this triangle. Again, I'm big on pictures. Forgive my drawings, they're never perfect. We're told that one angle is 110 degrees. Okay, so here's what we know. We know that these other 2 angles, I'm just going to call them A. We know that these 2 are the same. Okay, we know that these 2 angles are the same because of the word isosceles. Because we know that when 2 sides are equal, that also means 2 angles are equal. And the other piece we have to know is that when you have a triangle, all the angles add up to 180. That's a rule all the time. Every triangle, if it makes a triangle, the angles add to 180. So here's what we know. We know that 110 plus A have to equal 180. So if you want to solve for the unknown value, we need to subtract 110. And that means that A plus A must give us 70. Or 2 times A has to give us 70. Then you can divide by 2 here, see that A is 35. So each of these angles in the bottom are equal to 35 degrees. Now recap, you had to know in this problem that isosceles meant that 2 sides are equal, which also means that 2 angles are equal. You also had to know that the angles in a triangle add up to 180. To set this up, use a picture to help you set up the equation. I think it'll make it a lot simpler for you. As we look at this problem, remember in Module 11, we were a lot about geometry, which we've said in this video earlier is a lot about the words. Like there are meaning in these words and you have to decipher the meaning to help you solve the problem. So as we look at this problem, I start off with a right triangle. Now, saying that it's a right triangle tells us there is one right angle in it. Okay, that's important. So I have a right triangle and one of the angles is 35 degrees. What's the measure of the other angle? So here's what let's draw a picture. I've got a right triangle with a right angle. Now that right angle measures to 90 degrees. That's because that's what right angles always are. 90 degrees. And one of the other angles is 35. Now, we know, just like our last problem, that all triangles, the angles in them add up to 180. So if you want to call this one A, like we did last time, we called the unknown angle A, we need to add them up, and they should add up to 180. So if you want to add the 35 and the 90, you get 125. And then you can subtract the 180 and the 125 to get your missing angle, which in this case would be 55. Okay, so again, reading this problem, I had to decipher that a right triangle had a right angle. A right angle is 90 degrees. Those were connections I had to know. Could draw my picture to label the unknown angle, and then I needed to know that all angles in a triangle add up to 180. Then I could find the missing angle here. All right, for this problem, I have a right triangle, has legs of lengths 5 and 7. What is the length of the hypotenuse? Now, you could look at the word right triangle, you could look at the word hypotenuse, but these are giving you clues that you need the Pythagorean theorem. The Pythagorean theorem says, and again, you can find this on your formula chart, that a squared plus b squared equals c squared. Where a and b are the legs, so the 5 here is going to be our a, the 7 here is going to be our b, and we're looking for the hypotenuse, which is the c value. So I've got, going to replace the a with the 5. I've got 5 to the second. I'm going to replace the b with the 7, so I've got 7 to the second. And I'm looking for that hypotenuse. All right, you can go to your calculator to do 5 to the second. Remember, that is not 5 times 2. That is 5 to the second power. You've got to get in the exponent there on your Desmos. So that will give you 25. And 7 to the second, which will give you your 49. And then you can add those together. 25 and 49 will give you 74. And then you have to get the second power off of the c. And this is where you're going to go and type in your square root. Okay, if you are working in Desmos, here's my little tip. I type SQRT, and that prompts Desmos to put that little square root on it, and you can type in 74. Let's just type that in our calculator here. We're going to type in SQRT, and then I want you to type in 74. You are going to get a decimal in this one, but I want you to watch your wording. Does the wording in the problem ask you to round to the nearest tenth, nearest hundredth? Does it ask you to round to one decimal place? You're going to have to decide how to answer here based on the problem telling you how much to round. But this is how you type it in your Desmos graphing calculator. All right, let's look at this problem where we're trying to find all of the angles here in the drawing. Notice that we have two triangles going on, and so I'm thinking when I see triangles that I'm probably going to use that rule that says that all angles in a triangle add up to 180. In this particular triangle, if I look at the one on the top, there's two unknown angles, 3 and 5. That's hard to find if I have two unknowns. So let's look at the bottom triangle and see if we can work there. I notice that I have told that this angle at the bottom is 42, and then I have this symbol here indicating a right angle. So I know that that is 90 degrees. So I can find angle 1 here by using that rule that the angles in a triangle add up to 180. So I know that 90 plus 45 plus angle 1, and I'm going to just use that as my symbol for angle 1, have to equal 180. So you're going to add the 90 and the 45. You get 135. You're going to subtract that from 180, and you'll get 45. Okay. So I know angle 1 is 45 degrees. So you remember back from our other problem where we used the vertical angles, remember the angles that made an X? If they were across from each other, that they were equal. So that gets us number 3 here. Angle 3, as we know, is 45 degrees also. Okay. Also, I want you to look at angle 1 and angle 2. Notice that those make a straight line. And remember from our previous problem, the angles that make a straight line have to add to 180. So what we know is that angle 1 plus angle 2 have to give us 180. Now we know angle 1 is 45, so angle 1 plus angle 2 has to give us 180. So we can just subtract 180 minus 45 to get angle 2, and I get 135. Okay, so angle 2 is 135, and bingo, that gives us angle 4 as well. Remember, they make an X. They're across from each other. Then that's 135. So notice that as I'm finding the angle, I'm also labeling it in the drawing because it helps me to see what is next to do. And that is we need to solve this triangle at the top to find angle 5. We're going to go back to that rule that says that the angles in a triangle add to 180. So here to find angle 5, I'm going to do 92 plus 45 plus angle 5 gives me 180. So you can add the 92 and the 45 and then subtract that from 180, and that gives you that angle 5 here is 43. Okay, so we found all the angles in the triangle either by using the rule that all angles in a triangle add up to 180, or that angles that make a line add up to 180, or that vertical angles are congruent. Remember, if they make the X and they're across from each other, then they are equal to each other. Oh, that was a fun problem. All right, as we move into Module 12, we move into a little bit of statistics work. And this problem is a good example of kind of the reading and logic behind statistics and sampling. We're not going to have a lot of calculations in this problem, but that's okay. So let's read it, see if we can pick out some details. A study is being conducted on stress level during exams. Woohoo, we know those are true, right? The professor conducting the study uses 50 of their own students as test subjects and measures stress factors during the exam, which is the best answer. This sample is random because students are all the same regardless of the school. Sample is not random because there may be differences in how tests are administered in different schools. Or it's not random, but it could be random by sampling 10 students from a random selection of 5 random schools. So I'm going to, first of all, throw out A, right? It's not random because these students were selected because they were in the professor's class. If they weren't in the professor's class, they couldn't be randomly selected anyways. So the sample cannot be random. So I think that the decision is it not random, period, or could we make it random by sampling students from different schools? And I think the answer is B here. It's not random because we can't control how tests are administered at different schools. If we could make sure that all the tests are administered the exact same and then we randomly select students, then yeah, then it could be a random sample. But the way the exam is conducted could be a factor in the stress. So I think we have to go with it. It's not random because there's so many differences here that pulling students randomly is not going to be give each person and the factors that they are experiencing equal weight here. All right, in this problem, we're going to create a stem and leaf plot. So if you remember, a stem and leaf plot looks at the first digit as the stem, and then we write the leaves or the leaves. It may be easiest if I will do all the numbers that start with a 1 digit. So I've got the 13, the 15, and the 17. So what I'm going to do is I'm going to do my stems and my leaf. Let's put the stems over here and the leaves over here. So I'm going to start with the stem of 1, so that's the first digit, and then notice my second digits are 3, comma, 15, comma, 7. I have all of those. I'm going to mark them out just to show that we've already done them, okay? And next, let's do the numbers that have a 2 first. So I've got 25, 29, 26. So their stem would be a 2, because that's what comes first. And then I've got a 5, a 6, and a 9. Do I have to write them in numerical order? Yes. So 5, 6, and 9. Let me mark those off since we used them. Next, let's do the ones that have a 3 as their first digit. So we'll do this one, this one, this one, and this one. So I'm going to put a stem of 3. And then we start with a 0. And then notice I have 2 2s. Okay, so I'm going to write those twice. 2 2s. And then an 8 as the 1's digit is what I'm writing there. I've got 2 more to go. I've got the 41, so it's got a stem of 4 and a leaf of 1. And then I've got the 57 with the stem of 5 and a leaf of 7 there. So there's my stem and leaf. Remember, the stem is the 10's digit. The leaves are the 1's digit. If you have a duplicate number, yes, you write it twice. You write that leaf twice. Your leaves want to be in numerical order, and they are separated by a comma there. All right, in this problem, we're going to use the frequency diagram that we have to the right to answer our question. So let's make sure we understand what a frequency column or frequency diagram is. It's telling us that in the age range 0 to 4, there are 8 kiddos in that category, 8 individuals in that category. In the age group 5 to 9, there are 12 kiddos or 12 individuals. In the age group 10 to 14, there are 14. So I want you to think of this like if we were dividing them up into classes. So let's say we had the class that was 0 to 4. Maybe we would call these the pre-readers. There are 8 of them, right? And then we go to the next class and there's 5 to 9. These are elementary kiddos. And there's 12 in that room. Think of reading your frequency diagram in that way. So the first question is, what is the sample size? What we want to know is, how many people altogether are there in all the classes? Okay, so this is where you're going to add up your frequencies. You're going to add the 8 and the 12 and the 14, your 10, and then your 6 people in the 20s category, right? You're just going to add them up, and you'll get 30. Okay. B says, how many are in the 10 to 14 range? How many people are in the 10 to 14 class? Well, you look at your age category in your class 10 to 14, you've got 14 people there. So that tells you how many you have in that class. And then watch this one here. C says, how many are 14 or less? So how many are in the 0 to 4 class? How many are in the 5 to 9 class? Because they're less than 14, right? How many are in the 10 to 14 class? So in this one, you're adding those first 3 classes, and I get 34. Okay. Now, here's the hack on this problem. Calculation was super simple. All we did was add, right? I can put those in my calculator, but I have to be able to read this frequency diagram. So I want you to really think of them as classrooms, and the kiddos or the individuals that we put in those classes, if they fit that age category. It's going to make a difference because then you'll know how to read the frequency diagram to answer the questions, because the calculations here were pretty simple, but reading that frequency diagram is really the part that we have to focus on. All right, in this problem, we are going to look at a group of 8 children that produce the following heights. Notice they're in centimeters. What we want to do is to find the median, the mean, and the standard deviation. Now, friends, I'm going to show this on Desmos because I think it's really going to help us to use those features. If you are not using Desmos, please, please, please make sure that you pull open the Desmos link I have in the description of this video because we're going to use some really cool features from Desmos I want you to experience. All right, my friends, here's my Desmos calculator, graphing calculator, and I want to focus in on this bottom part where it says show the keypad. So let's expand that. And I want you to use the functions part over here. So choose the functions and you get a whole bunch of trig stuff. We're not going to use that. Go down to where you see statistics. This is where we want to be for this problem because look, A says to find the median height. So I'm going to choose median. And notice what Desmos does is it opens a parentheses. Now here's what Desmos is looking for, friends. It wants you to list those heights that we were given. I'm going to type them. 138 and then you put a comma. 135, 142, 141, 140, 137, 140, 131. The answer is giving you the median here. Yes, Desmos will find it for you if you know how to ask for what you want. So it's telling you that the median here is 139. Let us do the same thing for part B here, which asks for the mean. Go to line 2. We'll do this again. Open your keypad at the bottom. Go to your functions. Scroll down to where you see statistics and choose the mean. Now, I'm going to make it real easy for us. I'm just going to copy all these values because they're the same. I'm just going to copy those and drop them in here. I don't need that extra parentheses there. Oops, I don't need that one. There we go. We do need this one. Let's see. I probably have, I got an extra parentheses there. All right. So notice what I've done now is I've typed the mean and my list of heights, and Desmos is telling me the mean is 138. Okay. If I will use my calculator to do the heavy lifting for me, I just need to know how do I tell it what I need, what I want. I can even do part C here. Part C says find the standard deviation. So go to line 3, open your keypad, go to your functions, choose statistics, and you want the STDEV, standard deviation. Same kind of prompt, right? Still asking me for those values, so let me do that. Now it's telling me by this little triangle, something is not typed right. So I'm going back to the home and notice I have a double parentheses and Desmos doesn't like that. So I just deleted that extra parentheses out here. Here's my standard deviation. Okay. Pretty simple if I know how to tell Desmos what it is I want. So let's recap in this problem. To do the mean, the median, the standard deviation, any of those, we open the keypad in Desmos and use the functions. We scroll down to the statistics where I can choose whichever one I want to answer first. I click on it and then I type in all of my values. And here's the deal. You could have 10, you could have 20, however many values you want to find the mean of, however many you want to find the standard deviation of. You can do all of that here with Desmos. I'd like to finish up Module 13 here with a few review questions that are true and false. So the first one is the mid-range is the overall spread of the data divided by 2. Now this snip here I took from the formula chart on the very last page. And I want to draw your attention to the middle there, the mid-range. So notice that the mid-range is the overall spread of the data divided by 2. I think the key word here is spread. Spread would indicate that we were subtracting. We would subtract the highest and the lowest and then divide by 2. But you'll see that in the mid-range formula, we're actually adding. So if I were to say that the mid-range is the average of the lowest and the highest, that would be correct. But to say the spread, I think makes this statement false. Our next true and false says the range is the difference between the largest and smallest values. So again, coming from this final page of our formula chart, I want to draw your attention to the range, which is the fourth one listed in the statistics category. The range is the difference between the largest and the smallest value. You can see that difference meaning subtract here. So this is a true statement. Again, difference means subtract here, using your formula chart on the final page in the statistics category. Our final questions here, I put on the same slide because they're very similar, and so I want to draw your attention. The first one in blue says the mean can be affected by outliers, making it sometimes misleading. Or the red here, the median can be affected by outliers, making it sometimes misleading. And the correct answer here is that the mean can be affected by outliers. And this is a true statement, which of course means that the red one here with the median, that's a false statement. The mean is highly sensitive. If the values are really high or really low, it can really throw your mean off, but that does not affect the median. So I want you to have that in your notes for exam 2. Hey friends, thanks for hanging in there. If you got to this part of the video, you got all the way to the last question, will you comment the star emoji? I just want to give you the best encouragement. I know you are wanting to do your very best on this exam, and I want that for you. Go back through our problems again, make sure that you understand each and every part of it, and I hope this helps you do well. Thanks so much, everyone. Bye for now.